Hello YouTube, and welcome to this tutorial where I'll just be going over the introduction to R. Today I'll basically be wanting to cover, what data is, what vectors are, data frames, packages within R, and just get started with it. As you could see, I already have the R Studio opened up, and currently my working directory is set to my documents folder where I have an R developer folder in there, and I've created the intro to R. Now, for a moment, let's just treat R as a program that basically includes three data types. Okay, three data types, which includes numbers, strings, and booleans. Now, in this case, when multiple values are stored together, it's typically called a vector. Multiple values of the same data type is essentially a vector. And when multiple vectors are stored together, this new data type is known as a data frame. Starting off with our basic calculations. R can essentially work as a calculator, as you could see right here. If I do 5 plus 5 and run it, you'll see that I get a result. I get a 10 right at the bottom of the console. Now I can also do something like 100 times 3, which would then give me 300. And let me do something like 3 caret 3, which is essentially 3 to the power of 3, which would give me 27. And you can see right here. So essentially, you could use R as a calculator, and this is the very basic, capability of R. And so most of the mathematical operations that we are aware of, including modulus, division, it's something that you can perform using, R. So now this is the basic capacity. To show you if how this is useful and to build on top of what we've just learned, let me try and basically add the sum into a variable, into an object that basically holds the value. Now when I run this, you can see that sum, the operation 5 plus 5, has taken place, and when I run to see what the sum value holds, you can see that the sum basically holds the value of 10, which is the essential operation that we've performed in line number 5. In order to know where exactly and what exactly each of your objects hold, RStudio has a great feature which will allow you to look at all the variables and the objects that you've stored within this environment. To show you what that looks like, now let me just add this to an object called multiply and run this. And you'll see that multiply, an object that stores the value 300, which is essentially 100 times 3 stored into it. The same way, I can just do exponents and then run this. You can see exponent holds the value of 27 and the sum of 10. Now, you can also use these variables, or sorry, the objects that currently store the value to perform operations. So when I do sum plus, let's say, multiply, as you intuitively have probably already guessed, this should store a value of 310 because it takes the value that's stored in sum, which is 10, and the value that's stored in multiply, which is 100 times 3, 300, and adds them up together. You've looked at how R can now store objects that contain numbers. Objects within R can also contain strings. So let's take a look at that. Let me create an object called my name. And if I want to store in the string value, I can just open up quotation marks and then just type in my name. And you'll see that when I run it, you're going to get my name, which essentially holds a string value of my 3. A string is nothing but a combination of characters. It could be a combination of numbers. So if I type in my date of birth, you'll see that I can also enter numbers into it. So you'll see March 27, and then let me run that. You're going to see March 27. So that's basically essentially what objects with an R operate with. Like I said, you can store numbers, you can store strings, you can store booleans, which is nothing but a true or false. So let's get into talking about a key difference that you might have noticed when assigning an object with a certain value. Typically, we perform things like, let's say, sum1, a new object, equals 6 plus 9. But in this case, I've actually done sum2 equals 4 plus 3. I'm sorry, what I wanted to show you was instead of equals, I'll just do less than, minus, which is essentially, a leftward pointing arrow, and run both of them together. You will notice that, in fact, both the equals and the less than minus, the leftward pointing arrow, perform the same thing, right? 6 plus 9, it's assigned to sum 1. 4 plus 3, it's still assigned to sum 2. So why do we use this notation? It's basically a generic convention. You could use equals or the leftward pointing arrow. It really does not make a difference, but there are a few subtle differences as you go along within, diving deep into R that you'll see when used in functions. And for now, it's essentially beyond the scope of this episode, but we'll talk about the key differences later on when we get there. Okay, so now that we've covered what objects are and how values are stored within these objects and how you can, play around with the objects and perform mathematical operations, let's actually take a look at, condition-based operations or results of an operation that are based on a certain condition and provides a certain Boolean value, such as a true or false. So in this case, let me create an object called test, which stores in the value of or takes in which are 3 greater than 2. So to give you an understanding for what test holds, if 3 is greater than 2, it's going to store the value true. And if I now change this to 2 greater than 3, it should store the value false. And you can take a look at it right here. We've seen that test holds a value of false. Now false is usually represented by 0. To show you if that's true, let me actually do test plus test, which in this case, if it does store the value of 0, you should get the value 0. So test plus test, as you can see here at the bottom on the console, it is 0. It returns a value of 0. At the same time, if I go ahead and basically change this to 3 greater than 2, which we know is true, which is usually represented by 1, test plus test should return 1 plus 1, 2. So that's basically how Boolean operations are done. Now let's take a quick look at if condition. Now, if condition is probably the simplest condition that you'll run into. So it's also very easy to understand and perform. So you have if, the keyword if, and within the braces, I give a certain condition. So sticking to the same example as previous, I'll just say if 3 is greater than 2, then I open up my curly braces. And what happens is if this condition holds true, it enters this curly braces, and whatever is inside these curly braces, it performs that operation. So in this case, let me just create a variable called variable that stores in the value bigger. And let me go ahead and I want to print out variable to make it run this. Okay, I've run it. Now, there is an error that's come out. You can see here in the console, it says object bigger not found. And the primary reason for that is you can see that the condition is, it's gone through, the error is not here. The error is something to do with bigger. And that's because if I want to store a certain value, it shouldn't be outside the braces. Since I'm storing in a string is always bounded within a quotation mark. And now when I go ahead and run this again, you can see that the variable holds the value bigger. Now that you've taken a look at how if condition works, let's look at if else condition. Now, before we get into if else condition and what fits into the arguments, let's take a look at how you know what packages are available and what functions are within a package, and how do you use these functions. The simplest way of identifying or knowing what each of these functions are capable of doing, what arguments they take in, you just have to go to your console and question mark if else, which is the name of the function that I'd be using. And in our studio, the cool feature is that towards the right side, you're going to get this help condition. You can also use the graphical user interface, but the simplest command is question mark function name. The moment you get into that, this will basically give you an outline of how you use it. As you can see, if else is basically if else and a test condition, and then a yes or a no. What that means is you have to basically type an if else to start the function and give it a certain condition. So let's just do that. If else, and I'll give it a certain condition. Let me say if 3 is greater than 2, I want it to return the value bigger. If this is not true, then the second argument that it takes in is the false value. So what I wanted to do is this time instead of smaller, I wanted to return 0. Now let's see how this works. When I run this code, you will notice that since 3 is greater than 2, it is true, and so it would run the yes argument. Let me go ahead and change this. 2 is greater than 3. We know it's false. It should return the value 0. So that's basically how if-else condition works. Now, as you can see here, I have the object weekly.high that stores in these values. Now, to know what the function C does, I've gone in and typed in question mark C. Now, this basically is a function that allows us to combine various individual values into a vector. So in this case, I've taken random values, 34, 42, 31, etc. And I've bounded them within the function C, and this is basically stored in an object called weekly high. We're basically trying to take a look at how the operations are performed and how they're performed on vectors rather than individual numbers themselves. So let me just go ahead and say weekly high, which is an object that stores this vector. And into this, what I'll be performing is weekly.high, which currently are these numbers. And to these numbers, I'll just go ahead and add in, let's say 1. Let me run this. And you will notice that each of the number that's stored in weekly.high, which let me just go ahead and run, you have 34, 42, 31, the same as this list right here. Now, when I run this operation, what it would do is it would actually do a matrix addition. The way this works is, let me go ahead and print out weekly high. It would essentially increment each of the number within this list by 1. And that's basically what I mean by operations are usually performed on vectors rather than the individual numbers themselves, roughly following, more of a matrix algebra commands. Now, if this sounds too complicated, don't worry about it. It's pretty intuitive when you play around with it and you'll get an idea. So just go ahead, create a workspace and practice around, play around with these functions and conditions and mathematical operations. Now let's take a quick look at the types of data or data structures rather. Before we dive deep into what data frames are, let's get an understanding for some of the various types of data types. We have vector, which is a one-dimensional array. You can imagine them as blocks of storage units that store a certain data value. In this case, you can see the screenshot right here. Essentially, the row 1, which holds cats, dogs, pandas, lions, tigers. So let's say, for example, I want to access pandas, which is basically the third element in the first row. Since the index in any computers start with 0, it would be 0, 1, 2. The third element would be 0, 1, and 2. The next version of it is basically a matrix, which is a two-dimensional array which holds an m by n row by column. As you could see, you could visualize it as a cube, um, and it would look something similar to this. So in this example, let's say, for example, I want to access the element 90, which is basically C2 for our visualization. You could see that I would require a row and I would also require a column as a reference to be able to extract that particular data point. And we have multi-dimensional arrays, which essentially are m by n by pages, which is rows, columns, and you can imagine them as being stacked on top of one another. And in order to access this, I would require three elements. One, which page am I referring it to? And like a matrix, which element am I trying to reference? So in this case, let me say I want to access the element 90. I have to mention, page 1, C2. Hopefully, this makes a little more visual sense. The one thing that you would have probably noticed or observed that is in common is the fact that the data type that it holds is always the same. So let me go back and you would notice that the multidimensional array, it only holds integers, right? Whereas in the first case, you could see that the vector in the 1D array that we've taken, the example that it holds is essentially a combination of cats, dogs, which is, strings of data. And that's where your data frame is slightly different. Data frame is essentially a combination of vectors. As you could see, you have a combination of strings and also integers. Now, A is essentially the column A holds the names of characters. Column B holds the names of the actors. Column C holds in their ages, and column D holds in their role or symbolic role within the movie. And for those of you who are movie aficionados, feel free to just comment down below what movie this particular table is referring to. Hopefully this makes a little more sense. Let's dive deep into data frames in R. So hopefully that visual has given you a broad understanding for what data frames are. So now let's take a look at how do we create them. Let me just go ahead and replicate the previous example where I've taken the actor's name or name of character. Sorry, character. And what I'd be doing is I'd be using the C function to combine. And what were the names? And then Arthur was producer, let's say that. Now let me use the keyword data frame. So question mark data.frame provides us with how we can use the function data.frame. So the data.frame function is used to create a data frame. So let's do just that. I'll just say table and then create a data frame by using the keyword data.frame, and this takes an input of row names. So in this case, I just have to give it name of, name of. When I go ahead and run this command, you will notice that name of character not found. When I actually run this, I get an error, and it says error in data frame, name of character not found. The object wasn't found, and that's because I've run line number 41 directly. So it really does not know what name of character is, name of actor is. And the reason for that is you've not run it. And you can see in the environment window, you do not have these values stored. So let me go ahead and run the code. And now we can see name of characters is stored. Name of actor is stored. Age of actor I've gotten. Role of an actor I've gotten that too. And they all hold elements, four elements. One is a number, another, all three, the rest of the three are characters. Now, let me go ahead and run this. Now, R does its magic to essentially compile these and put them or structure them as a data frame. To take a look at how it varies, you'll notice that these four are essentially listed as values. They're essentially holding certain values, so they're vectors. Whereas in this case, the object table is now essentially what it sounds like. It's a table. So when I open it up, it has four variables, and you could see the spreadsheet-like view. So all I've done is I've run data.frame, the function data.frame. I've given it the arguments that essentially hold the values that it needs to save, and it combines that, and the table would essentially just look like this. So as you can see, that's basically the basics or a very quick intro level overview on how to use R, play around with R Studio, perform mathematical operations. We've also taken a look at if else condition. We've also seen how to get an understanding for what functions are within R, and we've actually played around with the C combine function that allows us to create data or insert data. We've also studied or looked into data frame. So for this video, this will be it. I'll be including a few useful links that you might want to take a look into to get a deeper understanding about data structures, and how R takes in data and plays around with data. For the next video, we'll be looking into how to read data into R. So it could be CSV files or other files or data formats, but we'll essentially be taking a look into those commands. So if you found this video useful, feel free to just leave a like down below, subscribe to the channel. I'll be uploading videos on a regular basis. And at the same time, if there's something that you've not enjoyed, or if you have certain questions, feel free to comment down below. There's also the dislike button, so feel free to do that as well, because that will give me an understanding for what you guys are looking for and not looking for. That's it for today's video. I'll be catching up with you guys in the next. Stay safe, take care, peace.